Hello, viewers. In this class, our activities will be basically based on how to establish the product rule for derivative, as well as the quotient rule of derivative from the first principle. So we're going to establish y is the product rule is v du dx plus u dv dx. Okay, we're going to establish that, and we'll also look at the quotient rule from first principle. Okay, if we have y as a function of u v, yu is a function of x, and the v is a function of x as well. Here, from the first principle, where our y will be y plus delta y. Okay, and our u will be u plus delta u in bracket. Then our v will be v plus delta v. Okay, here we move the y from the left hand side to the right hand side, and this become delta y is equals to u plus delta u, or close bracket, open bracket, v plus delta v minus y. And we know that our y is uv, so we, in place of y, we substitute uv. So delta y is equals to u plus delta u, close bracket, open bracket, v plus delta v minus uv. So our effort here is to open this bracket, to expand this expression, u plus the u, then v plus the v. And if we do that, this will become u, open bracket, v plus the u, the v, then plus the u, we also multiply v plus delta v minus uv. So u times v, that will give us uv, u times delta v, that will give us u delta v, plus the u times v, that will give us v delta u, okay, plus delta u times delta v, that will give us delta v delta u minus uv. As we can see from here, we see that uv minus uv they are already gone. Okay, recall that our left hand side is delta y. So here we are left with delta y is equals to u delta v plus v delta u plus delta v delta u. Okay, we know the essence is what we're looking for, the y, the x. So here we divide through by delta x. So divide through by what? Delta x. Divide this one by what? Delta x. We divide this by delta x. We divide this by everything here by what? Delta x. Here we see we take the limit of both, we apply limits to both sides. So here this will become limit delta x tend to 0, limit delta u also tend to 0, as limit delta v also tend to 0. So if this limit is applied, to all these functions, this will become delta y over delta x over delta x, and that is limit as delta x tend to 0. This will become, the limit also applied to this, this will become u limit as delta x tend to 0, or the v delta, that is the v delta x delta v delta x plus v as the limit of delta x tend to 0 here. I will have a delta u delta x as this limit as delta x tend to 0. We have delta v delta u all over delta x. Here, this limit here, this is a constant. So this limit is a constant. And when you apply, as this one tend to 0, this one become, as delta s tend to 0, this will become 0. So that our delta y over delta x become the y, the x, y delta u delta x become the u, the x, and delta v delta x become the v, the x. Okay, as this limit tend to x, this delta x, this is delta x, delta v delta x will tend to the v dx, so that our dy dx become u the v dx plus v du dx. So that is the formula for product rule. This is how it is derived. Now let's now look at if we have even for instance, we have y is equal to u v w. So our derivative here will become y. If we pick uv, that be u v dw ds. Similarly, if I find the derivative of this will become u w. This one will be the v dx plus, if I find the derivative of u, we now have a u vw du dx. Even if the function are up to 4, the approach is similar. Okay, so this is how to find the derivative of a function if the function is a product. Please, in our next class, we are going to look at how to find the derivative if the question is a quotient. It's in quotient function. All right. Please, all you help me do, help me subscribe, and also share with other platforms. Thank you. See you in my next virtual class.